All right, ladies and gents, welcome back from Christmas break. So I got some good news because as we enter into chapter 7, just to start us off from this Christmas break, it actually starts with some pretty simple stuff that you've probably seen before. So lesson 1 is multiplication properties of exponents. So we are going to take powers and monomials, and we are going to raise them to exponents and all that jazz. Okay, so first, what is a monomial? Remember, a monomial can just be a plain number, it can be a variable, or it can be the product. The key here is product. It has to be multiplication. It can't be division. And then it can't be division by a variable, and then it can't have an addition sign or subtraction sign because it must be a product, okay? So a constant then is just a plain number all by itself. So if you have a binomial or something with more than one term, more than one monomial, the number all by itself, and that's a word we've been using. So let's not waste any time here. The first type of questions that you're gonna have to do will just be determining whether or not something is a monomial. It's pretty basic. So A is yes. Why? Because you're multiplying 6 and M. E is yes because it's multiplying H and H, because why they can use the H squared. B is going to be no, and the reason was right up here. It only has one term and cannot have division by a variable. So with non-negative exponents, because this technically would be 3ab to the negative 1 when you have that b in the denominator. So that's a no. And why? Because b is to the negative 1. You could say that. Letter F is a no because there are two terms. This one and this one separated by the plus sign, cannot be separated by that. Okay, C is going to be yes because it's just a number. H is yes because it's just a variable, and D is actually also yes. I know you're thinking, wait, Mrs. Burish, there's a fraction bar in there, but the difference is this just has a constant 3, so it's really kind of like 2/3. 2/3 x squared y, so that is still a yes. All right? Okay, so how we are a little review of what a power means. Okay, if something, this whole thing is a power. Some number to an exponent is a power. Within that power, you have the base, the large number, and the exponent. The base is the number, it's the factor that you keep multiplying over and over and over. And then the exponent is how many times you multiply that particular factor. And really, I think you guys know this, so we're just going to keep going here. So if we are multiplying bases that have monomials that have the same base, powers, like here, they're both a 2. Well, it's like 2 times 2 and 2 times 2 times 2 times 2, which is 2 to the 6, because there's 2 plus 4. So when we're multiplying powers with the same base, keep the base, add the exponents. So keep the base. They don't say that in here. It just says add the exponents, but you leave the base alone. It doesn't become 4. You're not taking 4 to the 6th power. It is 2 to the 6th power. That base stays the same. Okay? So this is the premise of all we're doing today. All right, so how do we do this? Product of powers. So right off the bat, we jump in. A little more difficult. It's not just, hey, a squared and a to the 9th. Okay, we have a monomial 3a squared and a monomial negative 2a to the 9th. We kind of separate them out. Those coefficients, we're going to multiply them. 3 times negative 2 is going to give us negative 6. And then a squared and a to the 9th, add the exponents, keep the base, add the exponents, and that's what you get. All right, take a look at the second one. We have coefficients of 8 and 6. So 8 times 6 is 48. And now with the r's, I'm going to keep the r and add those, which is 5. Keep the s and add those exponents, which is 9. So kind of going to stress neatness here, boys and girls. I know that some of us struggle with that, but it gets a little difficult to read our exponents So if we write really small or we write, horribly, this is a little tough. So we got to try and be neat. All right. So we can use the product of powers to find a power of a power. So take a look at this. 3 squared to the 4th power. Well, just imagine that's 3 squared times 3 squared times 3 squared times 3 squared, which is 2 plus 2 plus 2 plus 2. It's 3 to the 8th. So when you're raising a power to a power, you multiply exponents. All right, keep the base, multiply the exponents. All right, it's kind of cool. Here's a couple examples in here. So 3 times 5 is 15. 6 times 7 is 42. But take a look at this. In this example, there's a power to a power to a power. Guys, just keep the base. 2 times 4 is 8. 8 times 2 is 16. You just keep going, okay? And again, keep the base. 2 times 2 is 4. 4 times 4 is 16. All right, so that's how we do those. Moving on to the second page in your packet. Your packet should be pink. This one is white so that you can see it nice and easy. So how do we do this when we are raising products to an exponent? Take a look at that. If we have T and W both, now notice the only way it means that both of them are to that power is if they're included in a parentheses. If it was just TW to the 3rd, the only one in this case, that would be T times W times W times W, because that 3 does not go to the T. So the parentheses are super important here. But guys, I just distribute, I know that's maybe not the right word, but I just distribute that exponent to each of the variables and or numbers. So T cubed, W cubed. Over here we have a coefficient, so you have to take 2 to the 3rd right there, and then y to the 3rd and z squared to the 3rd, multiply the exponents. So 2 to the 3rd is 8, y cubed, z to the 6th. And that's how we do that. Okay? So let's do some of these word problems here. We've got power of a product, geometry. We want to find the area of a circle. Remember, the area of a circle is pi times the radius squared. Okay, well the radius here is 3xy. So our area is going to be pi times 3xy squared. Notice all 3 of those, the 3, the x, and the y are in those parentheses. So we have 3 squared is 9, x squared, y squared, and I'm going to leave the pi at the end, and I'm just going to leave it. I'm just going to express it as a monomial. That's what they asked me to do. Done. I'm going to leave it times pi. Now, could I have taken pi in my calculator times 9? Yeah, but guess, you know what? That's going to be an irrational number and get sloppy. So we're just going to leave it like that. Okay, so here's where the fun stuff goes. Take a look at all of that. They're combining all the things that we just did, but all together. So in this first example number 5, let's see if we can blow it up. Zoom it. Oh, there we go. Perfect. So do you see that we have 2 terms, 2 monomials being raised to 2 separate exponents? I'm going to do that first because order of operations parentheses, there's nothing I can do inside those parentheses but exponents first. So I'm going to distribute that. So I've got -4 to the 3rd power. I got c to the 2 times 3 is 6, and d to the 3rd. All right. Now over here, I got parentheses and brackets. So guess what? First thing I'm going to do, I'm just take 2 times 4. So now I still have 2c cubed d, but now it's to the 8th because I took 4 times 2. All right. Over here, now I'm just going to leave this alone, -4 cubed c to the 6th, d to the 3rd, but now I'm going to distribute that. So I got times 2 to the 8th, c to the 24th, because 3 times 8 is 24, and d to the 8th. All right, well, what is -4 to the 3rd? -4 times -4 times -4 should give me -64. C to the 6th, D to the 3rd, times 2 to the 8th. Ooh, that's a big number. I'm going to cheat in my calculator over here. That's right, 256. I should have known that. C to the 24th, d to the 8th. Now, we're not done because we still have to multiply them. Believe it or not, I got to take 256 times negative 64, and I'm going to use my calculator for that. It is negative 16,384. Now, the powers keep the base and add their exponents. So their C, 6 plus 24, would be 30 as our exponents, and D, 3 plus 8, is 11. And there's your answer. All right, and then the other example in the box. Ooh, we've got fractions, folks. Oh, heavens to Betsy. Don't let it freak you out. Let's just do it just like we did the other one. So let's distribute those exponents first. So I got a negative 1/4 times to the 3rd, x to the 3rd, y to the 6th, and then 8 squared x squared y to the 8th. Okay, over here, let's simplify this. Negative 1/4 times, so that's going to be a negative 1/64. X to the 3rd, y to the 6th times 64, x squared, y to the 8th. Well, guess what, you guys? When I take negative 1/64 times a positive 64, I'm going to get a negative 1. Now, I could put a negative 1. Wouldn't even need to put that there. I'm going to leave it there. And then x's 3 plus 2 because we're just multiplying. So to the 5th, y's are 6 plus 8, so 14. All right. I've showed you just about everything I need to show you. Your assignment is going to be a little more elaborate. Let me see here. On the back of your page, you have the sheet. It's a copy right out of the book because we are doing an assignment out of the book from page 395. Don't worry, that is the one that's on the back of this page. And you're going to do easy, 21 through 55. Don't panic, odd. And then I want you to do number 56 and number 59. It's only 20 questions. You'll be fine. Okay? Good luck. We'll see you later.